Hi everyone, and welcome to this Saturday session with Exam Revision. I'm Robert, and I am going to be taking you through some Leaving Cert chemistry today. And in particular, we're going to look at Hess's Law and the calculations that are involved with that. So, as I've just said, we're going to look at Hess's Law. So, our learning intention today is to complete exam questions on Hess's Law calculations, and we will also have a brief summary of some of the key concepts that are involved in Hess's Law and that are needed to complete the questions. Now, as a reminder, Exam Revision is on social media platforms, so you can find us on Twitter, Instagram, TikTok, Facebook, and YouTube. Or, of course, you can go to examrevision.ie where you will find the full chemistry course done out in complete video format with H1 standard notes, self-correcting quizzes, and exam paper questions and solutions. So check out examrevision.ie if you have interest in that. So let's begin with Hess's Law, and the question on everyone's lips is, where does it appear in the exam? So let's take a look. So Hess's Law will appear on a Leaving Cert chemistry exam. It's either that or heat of neutralisation calculation that tends to come up. And if it is to appear, it will appear with the concept and chapter centred on fuels. So there you'd be looking at hydrocarbon naming and drawing. You would also be looking at the octane number. You would be looking at factors that affect octane numbers, such as dehydrocyclisation, catalytic cracking, etc. Fractional distillation would come in there as well, and all of your different fractions and the functions of them. This question is usually a question 6 in section B of the paper, and your calculation can be worth anywhere between 12 and 18 marks. So if you are thinking of doing Hess's Law and it's a question that you are confident on, you need to make sure you have a very good background in your organic chemistry section of the course, in particular focusing on fuels and hydrocarbons. To begin calculations on Hess's Law, we do need to know what Hess's Law is. So we have a definition here. The definition of Hess's Law is that the heat change for a given reaction is the same whether it takes place in one step or in a series of steps. So that basically means that a full reaction could be made up of lots of smaller reactions, and that the heat change to go from the start to the finish is the same if it was one full reaction or loads of smaller little ones. So we can see here that if we want to go from A to C, we can either go directly by step 3, or we can go from A to B and then B to C with steps 1 and 2 as outlined here. And if you went and got the heat change from A to B and the heat change from B to C and added them together, we would get that is the same as the heat change from A to C overall, which is step 3. So, in order to be able to complete calculations on Hess's Law, we do need to know certain concepts and theories from thermochemistry, and we need to know these because they're used in the phrasing of the question, and they're also important for when we come to forming equations in order to work with our target equation that has been supplied on the paper. So in order to complete Hess's Law calculations, we need to be aware of heat of neutralisation, heat of combustion, and heat of formation. So let's take a look at each of these and what they mean for us. So to complete Hess's Law calculations, we actually need to be aware of specific concepts within thermochemistry itself, and they are heat of neutralisation, heat of combustion, and heat of formation. We will need to know these concepts because when we're doing Hess's Law questions, it involves constructing balanced equations based off the knowledge that we have on what the three of these concepts are. So let's take a look at them. So heat of neutralisation, it says that heat of neutralisation is the heat change when 1 mole of H plus ions from an acid reacts with 1 mole of OH minus ions from a base. Now, it's highly unlikely that you will be asked to form a heat of neutralisation reaction, but you could be given one. So it is important that you know the definition and what it actually means. Next up, we've got heat of formation, and heat of formation is very important because we will be asked when we're doing Hess's Law, it will say using the heat of formations of, and they will give you a list of molecules that you have to make. And in order to make them, we need to know what the heat of formation is, or in order to form their balanced equations, we need to know what heat of formation is. So the heat formation of the compound is the heat change that takes place when 1 mole of a compound in its standard state is formed from its elements in their standard state. So an example of this would be, for example, to form carbon dioxide. So the heat of formation equation, or the equation for the formation of carbon dioxide, we know that carbon dioxide in its standard state, 1 mole of it in its standard state is CO2, and the elements that it is made from are carbon and oxygen. Another example would be water, which is H2O. Now we know that water is made of hydrogen and oxygen, but we can see that this second equation now is not balanced. But when it comes to heat formation, you have to remember that it is 1 mole of a compound that we are forming. So we can't change this here on the right hand side to 2 moles of water, because then it wouldn't be heat formation. So that must mean we must change the reactants, and to do so we must have half of our O2. So that is some examples of heat of formation, and we'll get to more of those as well when we're doing our exam questions in just a minute. The last one then that we need to know is the heat of combustion, and the heat of combustion is the heat change when 1 mole of a substance is completely burned in excess oxygen. So if you're asked about heat of combustion, for heat of combustion, take the molecule that they are asking you about, add oxygen, and your products will always be carbon dioxide and water. That will always be the case. So when you are doing a combustion reaction, add oxygen and to whatever molecule you have, and you will always get carbon dioxide and water. And then you can just balance that equation yourself by inspection. Now, the best way to put Hess's law into practice is through examples. So let's go and look at some exam paper questions. Now, if you wish to avoid using heat of combustion, heat of formation, heat of neutralization, etc., you may complete Hess's law questions using the formula method. And if you're using the formula method, this is your formula here, and it says the heat of reaction is equal to the sum of the heat formations of your products minus the sum of the heat formations of your reactants in a reaction. Now for this video, I'm not going to be using the formula method, but if you do want to get more content on the formula method, you can sign up to ExamRevision.ie, where there is an example of using the formula method there. But for today's video, I'm going to use the long method of doing heat of formation, heat of neutralization and heat of combustion, and this will help aid your understanding of what these heats and equations actually mean as well. So let's start with this example here. This example is 2018 and it's question 6, and it asks you to calculate the heat of combustion of methane thiol according to the equation, and they tell you that the heats of formation of methane thiol, carbon dioxide, water and sulfur dioxide are the figures that are listed there. So from this, let's go and work out the solution. So the first thing to do all of the time when you're doing a question like this is to write out your target equation. Now I'm going to highlight the target equation because I have it here already. So our target equation for this question is highlighted there in yellow. So that is the equation that we're working towards in this question. And it says that we can calculate it given a load of data about heat of formation of methane thiol, carbon dioxide, water and sulfur dioxide. So let's write out these heat of formation equations. So the first equation that we're going to have is for the heat of formation of methane thiol. Now methane thiol has the formula CH3SH. So that is what we want to produce, and we know heat of formation is in the elements in their standard state react to produce 1 mole of the product. So the elements in their standard state here would be carbon, hydrogen and sulfur. Now if we go and balance that, we can see we've 1 carbon on the left, 1 carbon on the right. We've 4 hydrogens on the right hand side, so that must mean we have 2 H2s, and then we have sulfur. That's balanced already, and we're told that the delta H value for that is minus 22.8. The second equation that we're going to form then is the heat formation of carbon dioxide. So carbon dioxide is CO2, so it is made from reacting carbon and oxygen, and your delta H value there is minus 393.5. The third equation then is for water, and we know water is H2O, and the elements that react in their standard states for water is hydrogen and oxygen. Now here we need to be careful because we can see that the oxygens are not balanced here, but we can't increase the number of oxygens in our product because we always want to produce 1 mole of our product in heat formation. So what we are going to do instead is we are going to change the number of oxygens that we have to a half O2. And now that equation is balanced and it satisfies our heat formation definition with a heat of minus 285.8. The final equation that we want to work with then is the heat formation of sulfur dioxide, which is SO2. And the standard state of sulfur is S, and the standard state of oxygen is O2. So our delta H there simply minus 296.8. And I've pulled those figures from this list of numbers that are here. So now that we have our heat formation equations written out, what we want to do now is we want to manipulate each one of these equations such that we are getting something from our target equation. So when we look at each equation, we need to identify what it is in that equation that is of interest to us from the target equation. So if we are to start with equation 1 here, I can see that in equation 1, what is of interest to me is the methane thiol, which is the CH3SH. Now I can see it's on the right hand side in my heat of formation equation, but in my target equation it's on the left. So what I need to do with equation 1 is I need to flip equation 1. So if I flip equation 1, it becomes CH3SH goes to C plus 2H2 plus S. And that gives me a delta H value. When you flip an equation, you must change the sign of your heat. So that gives me 22.8. Now the unit for all of these is kilojoules per mole for all of your heats. I'm just not writing that in just to kind of save space. So that is the first equation completed now. So I want to keep going. Let's look at equation 2. And with equation 2, I can see the thing of interest for me is the carbon dioxide. And that equation is ready to go because the carbon dioxide is on the correct side and the has the correct number in front of it. So I can simply write out C plus O2 gives me CO2. And my delta H value there won't change because I haven't done anything to the equation. So it's minus 393.5. Next equation we're going to look at is equation number 3. And if I look at equation number 3, I can see what is of interest to me here is the H2O, because the H2O is on the product side of equation 3. It is also on the product side of my heat of combustion or my target equation, but I can see I only have one of it in my heat formation equation and I need 2 in my heat of combustion. So what I'm going to do with equation 3 is I'm going to multiply everything in equation 3 by 2. So if I do that, what I get is I get 2H2 plus O2 gives me 2H2O. And if I multiply everything in my equation by 2, I must then also double my heat. So my heat value becomes minus 571.6. Now, the last equation I want to work with is equation 4, and I can see here the piece of the equation that is of interest to me is the SO2 or the sulfur dioxide, and I can see in my target equation that the sulfur dioxide is on the product side with 1 in front of it, and that is the way it is in equation 4. So with equation 4, I actually don't need to do anything to it. I can leave it the way it is. So we can just write out the equation as it is and say S plus O2 goes to SO2, and your delta H value, your heat value, won't change because you haven't done anything to the reaction, so it is minus 296.8. Now at this point here you have manipulated your equations and you have gotten as much as you can out of your heat formation equations. So we now need to go and work with these equations that are in blue. If we put them all together, the target equation should pop out with some cancelling that we can do. So let's do that. Let's write out all of the reactants on one side, all of the products on the other, and see what we get. So I'm going to do this on the side. I'm going to write out all of my reactants. So I can see I have CH3SH plus C plus O2 plus 2H2 plus O2 plus S plus O2. that is all of my reactants that I have. So I suppose if I just highlight those so that you can see where they're coming from. I won't use yellow because I've used that already. So green, red, let's go with a grey. It's very hard to see the grey. And let's go with one final colour. We'll go with a pink. So they are all my reactants. Now let's do the same thing for the products. Let's highlight them and write them out. So as you can see, I have the products just written out there. Now, when you have all of this done, you need to see, is there anything that can cancel out? So do we have the same thing on both the reactant and product side of our reaction? So I can straight away see that we have a carbon on the reactant on the product side and a carbon on the reactant side, so they can cancel out. We have two hydrogens on the product side and two hydrogens on the reactant side, and we have a sulfur on the product side and a sulfur on the reactant side. And now what I can do is I can go and write out my equation with what I have left. So if I go and do that now, what I will get is I will get CH3SH plus, if I add all my oxygens, that adds up to 3O2. And what that will give me is that will give me what's left on the product side, which is CO2 plus 2H2O plus SO2. Now we also need to total up our delta H values. So we can do that here. And when we total all of these values up, what we get is we get minus 1239.1. So to write my full answer now in a format that we would expect on the exam, here it is. You've got your CH3SOH plus your 3O2, and that gets converted to your CO2 plus your 2H2O and your SO2, and we get that our delta H value, or our heat change, is minus 1239.1, and that is kilojoules per mole. And if we compare this equation, for which I found the heat change, we can see that it matches the equation that we have at the start of the question, which is our target equation. Now, let's assign our marks in this question. So I'm going to assign the marks in green pen. So basically what we will get is 3 marks for the first flip. You'd get 3 marks for multiplying equation 2 by 3. And then you would get 3 marks for equation 2 and equation 4. And then finally you would get 3 marks for the final answer. So that is one example of Hess's Law. So let's try another example now of Hess's Law, and this is the 2023 question, and this was question 6 part D, and you can see that it was worth 12 marks. And the question says that a balanced equation for the complete combustion of an alkane, C15H32, in plentiful supply of oxygen is as follows. Calculate the value of the heat of combustion using the heat of formation of C15H32, carbon dioxide and water. So a very similar question to the last example, and let's work through it together. So the first thing I always note in a question like this is, what is the target equation? And the target equation is the equation that we're going to work towards, and that is here. This is the target equation because they're asking you to calculate the value of the heat combustion of the C15H32. Now, they also give you some information on the equations that you are going to need to complete this. So it tells you using the heat of formation of C15H32. So if it's heat formation, that means our C15H32 is going to be a product. And when you're talking about heat formation, you're talking about the elements that makes your product in its standard state. So that here is carbon and hydrogen, and carbon exists as C and hydrogen exists as H2. So in order to balance this equation, I must have 15 carbons on the left and I must have 16 hydrogens. That balances your equation, and we know the delta H value there is minus 428.8 from the question. The next equation that we're going to work with is the heat formation of carbon dioxide. So it's how do we form carbon dioxide, which is CO2. We know that that's formed from carbon and oxygen, and at that equation is balanced, so it has a heat of formation of 393.5. The last heat that we want to work with is a heat formation of water. So again, how do you form water? Well, you react hydrogen with your oxygen. And as explained in the last slide, in order to balance this out, it must be a half O2 here, because heat formation involves the production of 1 mole of your product in its standard state. So we're also told that our delta H value for this equation is minus 285.8. So these are the equations that we're working with. So I'm just going to number them 1, 2, and 3. So let's take equation 1 and let's take a look at what is of interest to us in equation 1. So I can see that the C15H32 is of interest to me in equation 1, but it is on the incorrect side for our target equation. So I know that the first thing I'm going to have to do with equation 1 is I'm going to have to flip it. So if I flip it, it becomes C15H32 goes to 15C and 16H2. That's just gotten from flipping the equation. And we also know that if we flip an equation, we must change the sign of the value for the heat. So that means the heat there is 428.8. If we look at equation 2 here, what is of interest for me in equation 2? Well, it is the carbon dioxide. And I can see that I have carbon dioxide in equation 2 and in my target, but there's a mismatch in the number. So I need 15 carbon dioxides, but I only have 1 in equation 2. So what I'm going to do is I'm going to multiply equation 2 by 15. And what that will give me is it will give me 15C plus 15O2 to give me 15CO2. Now, because I have multiplied the equation by 15, I must multiply my heat value, or my delta H, by 15. So that gives me minus 5,902.8. Next, we'll move on to equation 3. And I can see in equation 3, what is of interest to me is the water. I can see I have 1 water in my equation 3, but I have 16 in my target. So that would automatically tell me I need to multiply equation 3 by 16. And what that will give me then is it will give me 16H2 plus 8 O2s, 8 oxygens, because it's a half O2, so a half by 16 will give me 8. And that converts into 16H2O. Now, as I said already, if you multiply an equation by a specific number, you must multiply your heat value by that number as well. So we must multiply our minus 285.8 by 16. And when we do that, we get minus 4,572.8. Now, I have worked with all of my equations to try and match them with the target. So the next thing to do now is to add some of these equations together. So I'm going to do that over here on the right hand side of the screen. So I'm going to add all of my reactants and all of my products. So I'm going to go with the reactants first from my blue equations. So I have C15H32. Then I've got my 15C and my 15O2. And then I've got my 16H2 and my 8O2. So they are all my reactants. Now, if I was to highlight them for us, I can see the C15H32 coming from equation 1. I can see the 15C and the 15O2 coming from equation 2. And then I can see the 16H2 and the 8O2 coming from equation 3. And that's all my reactants dealt with. So now let's add in the products. And we get 15C plus 16H2 plus 15CO2 plus 16H2O. And these are all coming from the product side of our reaction. So if we take a look at the product side of the reaction, what we will get is as follows. I'm just going to highlight them for you. So I've just color coded them there for you so you can keep track of where all of these molecules and formulas are coming from. So now what we need to do is we need to look at our reactants and our products, and we need to cancel out what they have in common. So I can see there's a 15C on the reactant side and a 15C on the product side. Same for the hydrogens, there's 16H2 on the products and a 16H2 on the reactants. And that at the minute is all I can really see that I can cancel out. So let's write out the equation in full then and see what we're left with. So C15H32 plus the 15O2 and the 8O2 will give me 23O2. So that will give us 15CO2 and 16H2O. And if we check that, that does match up with the equation that is given in the question, which is our target equation. Now, the next thing I want to do is to sum up my heat values. So I can do that here. If I sum up all my heat values, I get an overall delta H of minus 10,046.5. So my final answer for this question is C15 H32 plus 23O2 goes to 15CO2 plus 16H2O, and that gives me a delta H value of minus 10,046.5 kilojoules per mole. And that is another exam question answered for you in full. So what we want to do now is we want to assign the marks to that question. So let's go. I'm going to do it again in green pen for you. So as we know, this was worth 12 marks. So there was 3 marks going for equation 1, 3 marks for equation 2, 3 marks for equation 3, and then 3 marks for your final answer written out in completion. So the marks were fairly evenly spread. So let's do one last example, and this example that I've pulled here is 2021 question 6 part D, and the reason I've pulled this one is because your target equation here is not actually given to you, so we are going to need to write out the target at the start of the question before we go and figure things out. So if we take a look at the question here, and this is worth 15 marks as well, so you can see it's slightly different to the previous questions we've done, but also more marks going for it because it's slightly more difficult. So it says the heat of combustion of ethane thiol, according to the following balanced equation, is minus 1867.5. So what they've done is they have given you one of the equations that you're going to work with and the heat value. And they then say using this heat of reaction and the heat of formation of CO2, water and sulfur dioxide, calculate the heat of formation of ethane thiol. So before we even begin this question, we need to look at the equation for the formation of ethane thiol. Now I know ethane thiol is C2H5SH, and I know that from the equation that they've had here, the heat of combustion of ethane thiol. So that is the ethane thiol formula. So once you have that, you should be able to figure out your reaction for the heat of formation. So our target equation is, the target molecule is C2H5SH. So the target equation would be, it's composed of carbon, it's composed of hydrogen, which is H2, and it's composed of sulfur. And if we go and balance the equation, we can see we've got 1 carbon on the left, but 2 on the right. So we have to put a 2 in front of our carbon. And then if we check our hydrogens on the left and the right, we've got 6 on the right, but only 2 on the left. So I need 3 batches of 2 to balance out the equation. So this here is my target equation, and it is what I am going to use the equation that's given in the question and the heats of formation. I'm going to use all of them together to get this target equation at the end. So let's do this question together. Okay, so as we can see now, I have just made the question a little bit smaller and I've brought my target over from the last slide. So this is what we are going to be working towards here in this equation. And with the target, we are going to be using a set of equations. So the first equation we're going to be using is the one that's given in the question, which is C2H5SH plus 4.5O2 gives you 2CO2 plus 3H2O and SO2. And you're told in the question that the delta H value for that equation is minus 1867.5. So that's easy because it's given to you. Now, the second equation that we're looking for is the heat of formation of CO2. We've done that twice in this video already. We know it's carbon plus oxygen gives us the CO2, and the delta H for that is equal to minus 393.5. And we know that this is the formation equation of carbon dioxide because we're producing 1 mole of our product in our standard state from the elements of which that compound or molecule is made. So number 3 then, it's the heat formation of water. So again, it's your H2O that you're forming. And we know water is made of H2 and O2. And as I've said in the past few videos, past few slides in this video, that we're producing 1 mole of our product, which is water. So we can't change the number on the product side. So that means I have to have half O2 for that equation to make sense. My delta H value there is minus 285.8. And then my last equation, equation 4, is the heat of reformation of sulfur dioxide. And I know sulfur dioxide is SO2, and it's made up of sulfur and oxygen like that, to give a delta H value, as per the question, of minus 296.8. So, as per the previous questions, we are going to take each one of these equations now, and we're going to do something to it in order that it fits in with our target that we have up here on the top of the screen. So with equation 1, I can see what is of interest for me is the ethane thiol, but I can see it's on the left hand side in equation 1, and in my target it's on the right. So that means I must flip this equation. So let's go ahead and flip it. So what I'm going to get is I'm going to get 2CO2 plus 3H2O plus SO2 goes to your ethane thiol, which is C2H5SH plus 4.5 O2, and that gives me a delta H. You have to remember, if you flip an equation, you change the sign of your heat, so that's going to give me my heat value of 1867.5. So if we look at equation 2 then, we can see what is of interest to me in equation 2 that matches up with the target is the number of carbons. And we can see up here in our target that we have 2 carbons in our target, but only 1 in equation number 2. So that means I'm going to have to double equation number 2. So that will give me 2C plus 2O2 gives me 2CO2. And again, you're going to have to double your delta H value. So delta H is going to be equal to minus 787 kilojoules per mole. If we take a look at equation 3 then, what is of interest to me in equation 3 is my number of hydrogens. And I can see the hydrogens are on the correct side in equation 3 as they are in the target. But I need 3 of them, so I must multiply my third equation that I have made by 3. So that then gives me 3H2 plus 1.5 O2 to give me 3H2O. And that gives me a delta H value of minus 856.5, and the reason for that is because if I triple or if I treble all of the contents of my balanced equation, I must do the same for my heat. So the last equation that we're going to deal with here is equation 4. And with equation 4, I can see what is of interest to me is the sulfur, and it's on the correct side and it has the correct number, so it's perfectly fine. So we can just write that equation out as is. Sulfur plus oxygen gives sulfur dioxide, and your delta H value there is going to be minus 296.8. So let's do a little bit of work now, like we would usually do. Let's put all of our equations in blue together, keeping our reactants on the correct side and our products on the correct side. So if I write this out, I'm going to get 2CO2 plus 3H2O plus SO2 plus 2C plus 2O2 plus 3H2 plus 1.5 O2 plus S plus O2. And then for my products, I'm going to get C2H5SH plus 4.5 or 4.5 O2 plus 2CO2 plus 3H2O plus SO2. Now, I'm just going to highlight them for you in specific colours so that you can keep track of them. So I have them highlighted there for you now. So if we go and cancel out things now that are in common on both sides, we can see we've got 2CO2 in the reactants and 2CO2 in the products. We've 3H2O in the reactants, 3H2O in the products. We can also see that we have an SO2 in the reactants and an SO2 in the products. And finally, we have 4.5 oxygens in the products. If we add all the oxygens we have in the reactants, 2 plus 1 is 3, plus 1.5 is 4.5. They actually do match up correctly. So if I write out what I'm left behind with then, I am left with 2C plus 3H2 plus S goes to the product. The only product that's left is C2H5SH, which is ethane thiol. Now the last thing we want to do is we want to add our delta H values together. And when we do that, we get a value of minus 72.8 kilojoules per mole. So in order to get full marks in this question, I would need to write out my equation in full. So I write out the target, which is what I've actually ended up with. We can see here that this equation I'm hovering over now does match our target. So 2C plus 3H2 plus sulfur goes to your ethane thiol with a delta H value of minus 72.8 kilojoules per mole. Now, the last thing we want to do, as we do in all questions, we want to assign the marks for you so that you know what marks you're getting and how you can maximize those marks. So this question has a little bit more work to it, or not as much more work, just more of a thinking mindset to it. So there was 15 marks going. So you got 3 marks for each of the equations that you have in blue. So for flipping, multiplying by 2, multiplying by 3, and keeping the same, you got 3 marks there. And then your final 3 marks was for your final answer with your full equation as written at the bottom of the screen. So that is a few exam questions for you to help you with thermochemistry. So that's it for today's Saturday session with Exam Revision. Thanks a million for joining along. Just to remind you, today we covered Hess's Law and we looked at the calculations and exam questions that are involved in it, along with giving you a summary of some of the key theories that you need to complete those exam questions. And just to remind you again, you can find Exam Revision on social media. We're on Twitter, Instagram, TikTok, Facebook and YouTube. Or of course you can go to the website examrevision.ie, where you will find the full Leaving Cert course tonight in video format with H1 standard notes provided, PowerPoint presentations, self-correcting quizzes, and of course access to Leaving Cert exam papers and solutions. So that's it for today's Saturday session. I wish you the best of luck with the rest of your studies, and hopefully I'll see you again at a Saturday session with Exam Revision very soon. See you guys.